So Dan and Alison asked me to talk about land use regression model. And then I look at the schedule, they gave me 1 hour to do that. So in the next 1 hour, you're going to become an expert in high-level statistical modeling. You'll be an expert in epidemiology, toxicology, and some level of GIS, Geographical Information System, all in 1 hour. Okay? All right. So I think, let me start off by, so I'm with University of Massachusetts, Amherst. I've been there for the last 6 years. But I started from here, and over the last almost 20 years working on air pollution in Accra specifically, but now has expanded to other places, including Rwanda. So we're also in Kigali now. So the topic is land use regression modeling, but I kind of recreate that to think of it in terms of how do we estimate long-term exposures when it comes to outdoor particulate matter pollution or outdoor air pollution in general. And then what do you do with that? What is the need for that? And so the summary of everything I'm going to talk about is right there. You can use those for policy evaluation. You can use that for climate or health impact assessment. So I wasn't here yesterday, late in the afternoon, but I heard there was some discussion with Dr. Adetum about EPI. So I went and remodeled my slide to start with that. So in environmental health, there are some key tools that we need to be able to do what we do. And one of them is exposure assessment. And this can take many forms. And then with that, you'll be able to do some level of environmental epidemiologic work. And then you also need some level of toxicology. When you put all these three together, then you have some level of evidence for policy or for any kind of intervention that you may consider, either at the population level or at anywhere that might be useful. The key difference here is that population level, epidemiology deals with mostly only population, and toxicology may focus on individuals or animal models and other forms of models to be able to do that. There are some key differences between them, but we'll come to that shortly. So to make it a little bit lively, I want to reason with you quickly what are some of the key differences between EPI and tox. So I just want a quick shout out from the crowd. Can you give one difference between epidemiology and toxicology? Who want to try? Anybody? I can call. Okay, yes, Steve. Toxicology looks like biological mechanisms underpinning some of the adverse effects that we may get. Okay? Great. Yes?
I look at geographical spread. It's specific. Epidemiology looks at geographical spread because, I'm saying that the epidemiology looks at the broader area or bigger spread,
okay,
and toxicology could be localized.
Okay, I'll take that. Yes, any more? Maybe one or two more. Yes, Francis Pope, Professor.
Epidemiology is looking at population health at some level. You know, not necessarily the whole population, but some part of the population.
Right. Yes, so population, group level, all of information. Well, that's good. So this is a summary of, at this level, I think will be enough to give you a sense. You can think of them in terms of how they handle their exposure. You can think in terms of what they target. And here I put there for talks, mostly you're targeting maybe individuals or animal models, but you're focusing on one particular pollutant at a time. You could have a control environment. So if I'm interested in how much or how toxic ozone is, I can remove every other pollutant and focus only on ozone in a very controlled environment and test that. So I can talk about causation because there is no other confounding in that system. It's highly controlled. On the other hand, population level, if I'm looking at EPI and I study the impact of ozone on human population, it's very complicated because you are not only in a real world scenario, you are not only exposed to ozone, but it's a mixture of everything. And you have other existing situations. So that gives you a sense. Now, so interested in EPI or air pollution EPI, the whole idea is simple. What is the relationship between a particular measured exposure and then health outcome? This is a typical way of looking at it. So basically, let's say you went to a facility or a community like Accra, and over a 1 year period, you document death. Anytime anybody die, you document it. And the same time the person die, maybe you also measure some level of exposure. In this case, let's say NO2. And you do that over a period. And if you can see, exploring that quickly shows you that there seems to be something going on here and here. When the number of deaths goes up, it seems that air pollution goes up. And then you do all of those. And if you look at that relationship, this seems to be a very strong relationship between the measured exposure and then the health outcome, in this case, which is mortality, right? So, but how do you know that actually it is the NO2 that is causing the deaths? We don't know. It could be anything else. But what you're seeing there is a very, very strong statistical correlation between these two. That is what we want to be talking about today. When we do our land use regression model, we're going to go to a point and start looking at a real relationship between our estimate of exposure and then any type of health outcome. So, how many ways do we assess air pollution exposure? And here I want to focus a little bit on the long term. Because for any health outcome to occur, you must have been exposed. And sometimes there is a lag between the exposed period and when you have the clinical manifestation of the outcome. So, how do we assess, for example, long-term exposure? And when I say long-term, let me define that. I'm talking about maybe, let's say 3 months, 6 months, 1 year. How do we do that? Those of you in air pollution, what are some of the ways we estimate long-term exposure? Again, I'm coming to the group. A lot of EPA folks here, so. Ben. Sorry, I know your name. Sorry.
So first of all, you have to do the long-term measurements.
Okay.
You measure for a period of time to know what is there for a period of time. And then
So you establish your monitors at
Yes.
a location,
yes,
and you continue measuring there
Yes.
for a long period of time. What information can you get out of that?
the concentrations
Okay? Over time.
over time. Yes,
So which can vary by time.
yes.
So when you have one monitor at one location, the best is that it gives you information on the level over time. So long-term temporal variation or seasonal variation, you can get that information.
Exactly.
So if you put it right here in this room, you have no clue what is happening at the hotel where you stay, right? Okay. Any other way that we measure long-term exposure? Anybody else? Let me call on the Liberian EPA. Liberian folks, yes.
In addition to in those levels, we also are able to select a particular cohort, maybe at an age range that you want to follow, and to have a kind of distribution. And then what we do is that we put it into indices like health or pollution index or health index modeling to determine whether the long-term effect is maybe carcinogenic or not.
Okay, so you move on to the epi side of things. Okay, so there are ways we think about them in our world, and many of you here are air pollution. So if you want to imagine 1 year, 6 month exposure, you can do multiple ways of measuring them. Some of them quantitatively, some of them not. So the first one I put there is to use an indicator as an indicator measures. So we do this a lot. We say household air pollution is related to certain health outcome. How do we measure them? Most of the time, no. We use the question very simple. Do you cook with wood or you cook with gas? And we characterize them. If you cook with wood, we assume that your exposure is higher compared to somebody who cook with maybe electricity. So we use that indicator variable to show long-term estimate of exposure, but we don't have quantitative information on that. That's the problem with that. Then the next one will be you can do stationary monitoring, which is what Ben talked about. We put monitors at places, and as we said here, many African countries don't have even one monitoring station that is very reliable. Okay? So, and that station only gives you information at that location over time. It doesn't tell you what is happening next door, in next neighborhood. And if you live in Ghana or been to Ghana or any African countries, you know how the situation is. If you move from this room, by the time you get to the next building, you could jump from maybe 10 microgram per meter cube to 100 microgram per meter cube, because there are so many localized distribution of sources. Somebody cooking by the streets, a car is on a dirt road, and all of those happening within a short distance. So there's high variability. But if you put your monitors at one location, you cannot capture that level of spatial variation in the estimate. And then we went on and said, okay, that's not good enough. So why don't we improve on that? Then you can do interpolation. Maybe take a few network of monitors, maybe 4 or 5 in Accra, and then use some geostatistical approach, and then estimate some level. The problem with that, it can be applied to a place like Ghana where there is high level of spatial variation. So that's also not useful for us. And then we said, well, now we can use satellite images too. So you fly the satellite over, you take the AOD or look at the column of the air, and then based on that, you can combine that with some ground level measurement, and then you estimate your information. Yeah, if you look at many satellite products in Africa, the cloud cover, they are not reliable too. But again, it can be on its own. You need some ground validation, ground truthing, to be able to have a very good data. And then there comes what we're going to talk about now, which is land use regression model. This is very simple. You want to design a network of monitors in a place that is dense enough, and think about them, what are some of the variables that actually predict at each of those monitors? And then you apply that information to a place where you have not measured, and create now some surface. So how good your model is would depend on how densely networked your measurements are, and how long, and in terms of space and time, you can build only spatial model, or you can build space-time model as well. So I'll be talking more about that. And then there are other models like physical model, dispersion model, chemical transport model, and things like that. So I'm coming back to Steve. You started a situation here in the first talk on personal exposure.